All right, in video 2, we're going to now focus on triangles. So basically this is lesson 3. So 20 through 23, we're going to tell whether the triangles are similar or not. If they're similar, we're going to give the reason. Okay, so that's one of the 3 reasons. The similarity statement and the similarity ratio. And we're going to this time go from the small figure to the large figure. If they're not similar, we're going to explain why not. Okay, so number 20. I'm given the lengths of 3 sides and the lengths of 3 sides. I'm going to see if they're proportional. So I'm going to match them up. So I'll start with 10, just because. 10 is the smallest of the 3, so it's got to match up with the smallest of the 3 over here, so that's 15, which reduces to 2/3. 12 is the middle. 18 is the middle, which reduces to 2/3. 14 is the largest. 21 is the largest, which reduces to 2/3. They all reduce to 2/3. So they are similar. The reason is side, side, side similarity. We have 3 sets of sides that are proportional. Okay? The similarity statement would be RQP, triangle RQP, is similar to, I named the small side first, so CB, and then finish it up with A. And then the similarity ratio, the smaller to the larger, would be 2/3. So there's everything I needed for this problem. Okay? 21. Again, I'm going to check my sides. So I have 3 and 2, 4 and 6. What matches with what? Well, 2 is the smaller side of the 2 here. So 2 matches up with the smaller side over here, which is 4. That reduces to a half. 3 matches up with 6, which reduces to a half. So that's only 2 though, so it's not side, side, side. But hopefully you see that we have vertical angles here. So those are equal. So we have side angle side similarity. The statement then would be triangle, and I'll just say GMK. So GM, I named the longer side, so I want to name the longer side over here first. So SM, and finish it up with P. And then the similarity ratio, so the ratio is 1/2. Over here, we got these 2 angles are both right angles, so they're equal. So 3 matches up with 6, which reduces to 1/2, and 4 matches up with 10, which reduces to 2/5. Uh-oh, those aren't the same. These are not similar, since the sides are not proportional. So I can't go any farther with this one. Okay. Last one here on this section. AC equals 4. CL equals 8. CB equals 6. So I also have this here. Okay, so I got one thing I do know is I've got these 2 angles are congruent, vertical angles. But I have parallel lines, which means you want to look for corresponding or alternate interior angles. And I have alternate interior angles here. Angle A is an alternate interior angle with angle G. So angle A is congruent to angle G by alternate interior angles theorem. So now I can say that the triangles are similar because of angle-angle similarity, right? Angle-angle similarity. So that means triangle, I'll say ABC, is similar to triangle. I named A first, so I need to name G first, GLC. And then the similarity ratio. Now that's why I gave you this stuff right here. What matches up? Okay, well look at the angles that are marked. The side between them is 4. I didn't give you the side between them here. So 4 matches up with this one over here, which I don't know. Which means 6 matches up with 8. Reduces to 3/4. So the similarity ratio, which I can say here, yes, I know I only have 1 pair of sides that I know, but I've already established that they're similar by angle-angle. So the similarity ratio here is 3/4. So I have a lot of problems here where we're just going to start solving for variables. So I'm basically doing lessons 4, 5, 6, all in this part right here, which has a lot of theorems in it. That's the right triangle stuff. It's also just got some similarity in it from lessons 1, 2, and 3. But it's kind of a mix of everything, which is what the test is going to be. I'm not going to get through all these on this video. I'll finish them up in the next video. But I'm just going to go for a little bit, and I'll stop when I feel like it. Okay, this one, I first have to determine if they're similar. And they are because of angle-angle similarity. So if they're similar, now I can set up a similarity ratio, which is 8 over 16. Those are matching. So 8 over 16, my similarity ratio is 1/2. Now I can use that to find y. So 1/2 equals, 4 is on the smaller triangle, so I'll put that on top. Y is on the larger, cross multiply, y equals 8. X equals 63. Angles are equal, even in similar triangles. So x equals 63. Number 25, I see this angle right here is equal to that angle, which means this is an angle bisector. And now I can use angle bisector theorem, which was lesson 6, which just says 12 over 6 equals 20 over x. So 12x equals 120, x equals 10. Okay. I see a right angle here, and I see a right angle here. That means this is an altitude. And this is lessons 4 and 5, depending on how you like to do these. I'm going to use the shortcuts because I encourage the shortcuts. But if you want to separate and redraw these, go right ahead. Okay? The shortcut that I'm going to use here is corollary 2, which says the leg of the large triangle is the geometric mean. The leg of the large triangle is the geometric mean of the adjacent hypotenuse segment, so 8, and the whole hypotenuse, which is 8 plus x. There's my proportion. Now I'm going to go ahead and separate and redraw this one. I'm not going to do this for every problem because it would take too long. I'm going to separate and redraw. So I'm going to draw the small triangle, and I'm going to label that 8 and 12. And then I'm going to do the large overall triangle. And the leg here is 12 and 8 plus x. Right, the whole thing is 8 plus x. So then the small 8 matches up with 12, and then the hypotenuse matches up with 8 plus x, which is what I had here. 8 matched up with 12, hypotenuse matched up with hypotenuse. So just showing you how the shortcuts relate to separate and redraw. Now let's solve. So 8 times 8 plus x equals 144. 64 plus 8x equals 144. 8x, 144 minus 64. 80, and x equals 10. Okay. Moving on. Lots of them on the next page. All right, so I'm telling you here the figures are similar. Number 27. So I can set up a similarity ratio. I'll just do 8 over 6, which reduces to 4 over 3. That's my similarity ratio. And now I can use that to find other sides. So I'm going to find z by doing 4 over 3 equals, 12 is on the larger, so the larger I put on top. Z is on the smaller. Cross multiply, I get 4z equals 36, z equals 9. X is an angle that's equal to the corresponding angle, so that's 42. Y is an angle, but I don't have that yet. But it is a quadrilateral, so there's 360 degrees. So 360 minus 90, minus 90, minus 42, 138. Next one, another right triangle problem. So I got right triangle. That's an altitude. I know that because of the right triangle here, or right angle here. So I'm going to, again, it's the same shortcut. It's corollary 2 that I used in problem 26. The leg of the large triangle is the geometric mean, I'll put here and here, of the adjacent piece, so 6, and the whole thing. Well, the whole thing here is 6 plus x minus 6, right? That's the whole thing, that plus that. Well, 6 minus 6 is 0, so that just simplifies to x. So the whole thing here is just x. Okay. So 6x equals 100. 100 divided by 6, not a good number, but I can reduce that to 50 over 3. If you wanted to give a decimal, it would be what? 16.6 repeating? But there's my answer there. 29, I have angle similarity. So the triangles are similar. There's an angle similarity. Now I want to get a similarity ratio. X matches up with, notice how it's between the two angles that are marked. Between the two angles that are marked is 8. So X matches up with 8. That's not where I get my ratio. Where I get my ratio is 9 to 6. So 9 to 6 gives me my ratio, which is 3 over 2. And that's what I'm using to find x and y. 3 over 2. Let's go ahead and find x. X is on the larger, so I'm going to put it with the larger. And x is already established, matches up with 8. So 2x equals 24, x equals 12. How am I going to find y? Because I don't know the hypotenuse here. Well, you could use the Pythagorean theorem to find the hypotenuse because it's a right triangle. So 6 squared plus 8 squared equals 10. I already know what the answer is, but h squared. But that's going to equal 100 equals h squared, square root, that's 10. So now I can use my 3 over 2. Y is the hypotenuse in the larger. 10 is the hypotenuse in the smaller. 2y equals 30. Y equals 15. Okay. 30, another of the right triangle. Right triangle here. Sorry, yeah, right triangle here. Right angle means this is an altitude. I'm going to go ahead and find y first. That's corollary 1, which says the altitude is the geometric mean. As soon as I say geometric mean, I'm going to put that there. Of the two hypotenuse segments, so 9 and 16. So y squared equals, 16 times 9 is 144. Square root of that, y equals 12. I don't need to put plus or minus on this because it's a side length. No need to put the negative. All right, x is a leg of the large triangle, corollary 2, which says that that's the geometric mean of the adjacent piece, so 9, and the whole thing. Well, 9 plus 16 is 25. Excuse me. So I get x squared equals, I believe that's 225. Square root of 225 is 15, I believe, just making sure. Yep. So x is 15. Z is another leg of the large triangle. It's the geometric mean of the adjacent piece. So the adjacent piece is 16. The whole thing is 25. Z squared equals 16 times 25 is 400. Square root of 400 is 20. Okay. 31 is side splitter, sort of. I mean, it's a corollary with side splitter. I see parallel lines. I need that for side splitter. Which just says it divides these proportionally. Parallel lines will divide these proportionally. So 14 over 7 is going to equal 11 over x. Cross multiply, this one's going to be 14x equals 77. 77 divided by 14 is 5.5. I'm going to do 32 as the last one on this video. So, again, right triangle. Notice how I'm doing a lot of these because I think these are the most tricky, but I'm mixing in other ones, and that's how the test is going to be as well. I'm mixing these things in. All right, so I'm going to do, it's very similar to number 30, actually. Again, this is an altitude. I know that because of the right angle. I gave you the whole hypotenuse here is 14, but I gave you this was 8. I can figure that piece out pretty quickly by doing 14 minus 8. That's 6. The altitude is the geometric mean of 6 and 8. So y squared equals 48. Square root, break that down, I'm going to get 12 and 4, 4 and 3, 2 and 2, 2 and 2. So that's a pair of 2s, another pair of 2s. That's a 2 times 2 on the outside, so that's a 4. with a leftover 3. X is the geometric mean of the adjacent piece, so 6, and the whole thing, which is 14. So x squared equals 84. Square root of 84. That's 4 and 21. That's 7 and 3. 2 and 2, so it's a pair of 2's. So that's 2 radical, 7 and 3, multiply those back together, radical 21. Okay, and then z, we'll do it over here. It's a leg of the large triangle, so it's the geometric mean of the adjacent piece, 8 and 14, the whole thing. 112, so z squared equals 112, square root. Well, I know 8 and 14 multiply to 112. 8 is 4 and 2, 2 and 2, 7 and 2. So a pair of 2's, and another pair of 2's, so it's 4. Left over 7 on the inside, so 4 radical 7. Okay, and that's it for this video. I'm just going to pick this right back up when I start the next video.